Well, that was interesting. I thought that I thought that I was all done, but I'm not all done. Apparently, I did not save one of my videos correctly, so I am re-recording Angry Aggregates Part 3. It won't be as good this time. The first time that I recorded it was a work of pure light. It's brilliant beyond compare. Dr. Fraser Crane would buy tickets to see me do the first iteration of this. This one will stink in comparison. It will be a Staten Island dump in comparison. Will hold no candle to the first recording. But the whole point of this one is that in the first two videos, we were able to update statistics in a helpful way to get us faster queries and better plans. And I want to use this video as an example of where, well, we can use statistics to get a better plan, in other words, better guesses at how many rows are going to come out of things. We still need an index in the end to get us across the performance finish line. And so let's get going on that, because I'm not getting any younger here. So let's look at the query plan for this query. And we can see that it ran for around about 2.9 seconds. And similar to other queries that we've run here, we have what starts off as a good guess coming out of the old post table and going into a compute scalar. But then by the time we get to a hash match aggregate, SQL Server way overestimates how many rows it can get squished, how many rows it can actually aggregate down. So SQL Server thinks that it can get us down to what, 130,000 rows, but no, wrong. We stop at 1 million rows, which isn't the end of the world. In the last two demos that we saw, there were some really bad estimates that really screwed us. But this one, not too bad, about 900,000 rows. And at the end of the day, well, it just doesn't really do a whole lot of bad to us. I'll tell you why. If you look at the entire top row of this query plan, every single one of these operators has run in batch mode. So SQL Server 2019, batch mode on row store. I'm not using column store indexes here, but because this query is big, bad, burly, expensive enough, the optimizer's like, maybe we'll try batch mode here. And it's right to. So all of these things run in batch mode. This index scan also runs in batch mode. So everything is in batch mode. And I'm telling you that because what I want you to understand is that each one of these operators, up until we hit the gather streams, which is in row mode, is keeping track of the time just for itself. So we have the gather streams is in row mode, so it will calculate the time across all of the child operators that had time associated with them. So there's the top end sort, which ran for 0.004. There's the filter, which barely even registered time. And going across, nothing really. 866 milliseconds here, and then 2.3 seconds here at the scan of the post table. So thinking back to the other queries we tuned, where when we updated statistics past a certain point, SQL Server would either have a more reasonable guess about how many rows would be aggregated, or it would look at the prospect of aggregating those rows and say, we're not going to get anything out of this, we're just not going to do that aggregate. Let's say that we updated statistics here so that we canceled out this hash match aggregate. We would only hash match aggregate. Hash mash, that should be a new thing, right? Even if we got rid of this, we would barely be shaving a second off this plan. 866 milliseconds. That to me is not like, hey, we tuned the query, we got rid of 966 milliseconds, we're saved, oh, we're going to get a raise, we're going to get a bonus, we can, oh, we're such good query. That doesn't do it for me. So what I would like to do is digress just a teeny bit. And what I'm in a separate window, I am going, actually I already did that. I already set this up for myself, and there I went making extra work. So I'm going to create statistics like I did in the last two videos, except this time I'm going to use full scan rather than a smaller percentage. And I'm going to create them on the owner user ID column in the post table, because that is what this hash mash is trying to aggregate here. If we look at what happened, SQL Server was like, ooh, we're going to aggregate the owner user ID column. It's going to be great. Excuse me, I got champagne stuck in me, and that made me do like a weird, like Disney cat voice, like Hep Cat voice or something. But where that came from, but that's what SQL Server tried to get up to there, and that's not going to go so well at all. Now, I think generally it was maybe right to try to aggregate the owner user ID column, because when we look at the uniqueness, the distinctness, the selectivity of the owner user ID column, it is just not. So out of around about 17 million rows of user IDs, only about 1.4 million of them are unique. Now this is not unique at all. It's 8.37% unique. It's not terribly helpful. So I can see why SQL Server would want to try to deduplicate values from those rows prior to joining them off somewhere else. That makes sense to me. If you have that many non-unique values, what's the point of doing anything with them? So with those statistics in place, let's go back and run our top 500 query. And let's see how we do. Well, we didn't. Everything stayed exactly the same. So this time, remember we had an explicit hash match prior to doing our hash join before. Now, we don't. The join order flipped, first of all. The post table is over here rather than being somewhere up over here. So the users table starts off on the outside, and the users table is the ID column in the users table that we're joining to is unique. Okay, fair enough. We don't have any attempt at pre-aggregation over here, which is okay, because this hash join is a bitmap creator. You can see that here. This is something that shows up again in batch mode plans, where there is a hash join, rather than like in row store plans where you would see the bitmap creation operator. So that happens here. So we build our little bloomy filtery type thing, and we apply that bloomy filtery type thing over here, where we get, ooh, look at that, bitmap 1015. That gets applied over here. So SQL Server skips the aggregation on the inner side, because we have the bitmap doing some work for us. But we also don't really save any time. Most of the time that we spend in this plan is scanning the post table. So this isn't a question of we needed better statistics to make better guesses here or here or here. We have actually under guesses and all these things, so we didn't even like fully flex on those. But we're also not really attacking the problem in this plan by just updating statistics, because most of the time in this plan is again over here. If we want to save time in this plan, we need to save time where we're spending it, and this is true of any query plan that you look at. If you want to save time, you must see where you're spending time, and you must stop spending time there, obviously. And so we can do that with this index. Now, I'm creating this index artisanally. I am very specially creating this index filtered to where parent ID equals 0, not because it gives us any superpowers here, just because I want it to create more quickly. Because I don't want to sit there and make you wait and me talk and blah, 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 blah. I've done enough of that today. I don't want to do anymore. I'm done with it. But with that index in place, we have a much faster query. We go from about 3 seconds down to a little under a second. Why? because we attacked the part of the plan where we were spending more time. Now we get a much quicker scan of the post table. We're still scanning, but that's okay. We still have our bitmap get probing over here, so that's exciting. But this was where we were spending our time, and since we eliminated the time that we spent there, then we were able to have a faster query. Now SQL Server is going to tell us that if we had an index on reputation and display name, we could reduce the cost of this query by like 70% or so. But I mean, do I really need to reduce this from 230 milliseconds down to something smaller? Even if I reduce that by 70%, I'm not amazed by anything. Who knows? Maybe the plan would go serial and take twice as long. I don't know, and I'm not going to find out. But if we look across now, none of these operators are really spending a significant amount of time doing anything. So I think we're done here, finishing in under a second. I mean, that's just me, though. Anyway, thank you for watching. Thank me for re-recording this when I could have been doing something else. And I will see you... I don't know. I recorded in real time. I recorded 2 other videos after this, but since I'm coming back, I don't know. It's all just weird now. I'm not sure how this timeline is gonna sync up, but I'll see you when I see you. Probably in another video. Hopefully, not like shortly in real life, because that means you're a weird stalker. I will punch you until you stop moving. Anyway, thanks for watching. I will see you some other time. Goodbye.